In the previous video, we looked at the first error detecting method, which is called parity check, and we said we've got two methods of doing parity check, which is either by using odd parity or even parity. And we said it all has to do with the number of ones when doing either odd or parity check. So for odd parity, we said the number of ones should be summing up to an odd number, and then if it is an even parity, the number of ones should be summing up to an even number. So welcome to my channel Koda Entertainment TV, where we focus on computer science, ICT and mathematics. So today we are looking at the second method of detecting errors in data transmission, which is checksum. So checksum, usually it is a value that is calculated from the data that is to be sent before being transmitted. Then it is sent together with the data. So when the data is received at the receiving device, then a checksum value is again calculated from that same data, and the checksum value that we get after recalculating at the receiving device would then be compared with the checksum value that was obtained when it was calculated before the data was transmitted. So this is how checksum works. So let me just give you a few steps that we should follow when using modulus 11. So when using modulus 11, all the numbers that will be given on your that will be given for you to calculate the checksum value on, they should be weighted on a scale. Let's say you've got 5 numbers that you want to calculate the checksum value on. It means now then the fifth number should be weighted with the weight of 6. Right, and then the fifth number should be weighted with the weight of 6. Then the fourth number should be weighted with the weight of 5. The third number should be weighted with the weight of 4. The second number should be weighted with the weight of 3. Then the first number should be weighted with the weight of 2. The reason why we do this is that the checksum value should be calculated by 1. Right, the checksum value should be calculated by 1. Again, the reason being that the reason for us doing that being that if we multiply any number by 1, it will not change. Right, it will not change. So you will understand this better when we do the proving the checksum value, because first of all we calculate the checksum value, and then for us to find out whether the checksum value is true or false, is true or not, we need to prove. So by proving, we would now be including the checksum value and then calculate the checksum value with the weight of 1 and then adding all the products. If the remainder that we get after all the operations we are supposed to do is 0, then it means the checksum value is correct. But if we get any remainder that is not 0, it means the checksum value is wrong. So this is how checksum value works. So let me demonstrate to you how it works practically. Right, so we want to calculate the checksum value on this product code. So we have got product code 586177755. So we want to calculate the checksum value. So using the steps that I gave you, let us weight our product code. So from left to right, we start with the greatest number. So our product code has got how many numbers? It has got how many digits? 1, 2, 3, 4, 5, 6, 7, 8. So our product code has got 8 digits. So when weighing these digits, we need to start at 9. Why? Because we want to reserve weight 1 for the what? For the checksum value. So it means the weight for 5 would be 9. The weight for 8 would be 8, and then for 6 it would be 7, for 1 it would be 6, for 7 it would be 5, and then for 7 it would be 4, and then for 5 it would be 3, and then 2, like this. So now we multiply, right, the respective these numbers. We multiply the single digit of the code against its weighting, right? We multiply this single digit of the product code against its weighting, and then we add. So this is what we do next. So we do 5 by 9, right? 5 by 9 plus 8 by 8 plus 6 by 7 plus 1 by 6 plus 7 by 5 plus 7 by 4 plus 5 by 3 plus 5 by 2. Now 5 times 9 is 45, plus 8 times 8 is 64, 6 times 7 is 42, and 1 times 6 is 6, 7 times 5 is 35, 7 times 4 is 28, 5 times 3 is 15, and then 5 times 2 is 10. Now we add, so that's the, that's another step. We now add these products. So let us add the products. 45 plus 64, 45 plus 64, it will give us what? 109. So these two will give us 109. Because 40 plus 60 is 100, then 5 plus 4 is 9. So here we get 109. Then 42 plus 6, it gives us 48. 48. 35 plus 28, this will give us what? 8 plus 5 is 13, 63. So it will give us 63. 5 plus 8, 13, 3, carry 1. 1 plus 3, 4 plus 2, 6. Then 15 plus 10, obvious, this is 25. Now 109 plus 48 plus, alright, 109 plus 48, 9 plus 8 is 17, 7 carry 1, 1 plus 4 is 5, and then 1 plus 0 is 1, plus 63 plus 25, 63 plus 25, 3 plus 5 is 8, 6 plus 2 is 8, 88. So 157 plus 88, we get 8 plus 7, that's 15. 8 plus 7, 15, 5 carry 1, 6 plus 8, 6 plus 8, it gives us 14, which is 4 carry 1, 1 plus 1, 2. So we get 245 after adding all these products. So we now need to divide by 11, because this is modulus 11. So we divide this result by 11, like this. So 245 divided by 11, 245 divided by 11, 11 into 24, 11 into 24 is 2, for 22 leaving a remainder of 2, and then 11 into 25 again it's 2, leaving a remainder of 3. Right, so 22 remainder 3. Then what happens now? We subtract the remainder from our divisor, right? We subtract the remainder, which is 3, from our divisor, which is 11. So 11 minus 3 would be equals to 11 minus 3 is what? 8. So our checksum value would be 8. Checksum value is equal to 8. That's our checksum value. So this is how a checksum value is calculated. So that was how we calculate checksum value using the method of modulus 11. So simple steps, just in summary. First, we need to weight the number that we are calculating the checksum value on. We need to wait. So by waiting, we are simply placing the values underneath each and every digit as an individual. It can be a product number that we want to calculate the checksum value on. It can be a book number and so forth. So what we simply have to do, we need to create a simple table like I demonstrated. Then we put our weights just below those individual numbers of a product number or a book number, and then after that we need to calculate the individual numbers that makes up the product number or book number by its respective weight, and then after that we add the products. After we add the products, we need to divide the sum by 11. Since we are using modulus 11, we need to divide the sum by 11, and then we get the answer and the remainder. Then the last step, we would need to subtract the divisor, in this case which is 11. We subtract the divisor, we need to subtract the remainder from the divisor. For example, in this case we subtracted the remainder, which was 3, from the divisor, which is 11, for us to get 8 as our checksum value. So in the next video, we are going to be demonstrating how to prove, right? We need to prove whether the checksum value that we got, whether it is correct or not. So this is what we are going to see in the next video. Thank you very much for watching my video. Please let's continue sharing these videos. Subscribe to my channel so that the algorithm would be able to recommend my videos to many platforms. So please share my videos to as many platforms as possible. Also subscribe to my channel. You can contact me using the numbers that are appearing on your screen, and I also have social media platforms that that are provided. The links are provided in the video description below, so you can follow me on Facebook, LinkedIn. You can also call me or WhatsApp me. Thank you very much. See you in the next video.